This is a small LED rotating display stand from eBay or Amazon. They're all much the same. What I want to do with this is try and improve upon it. Now, what you have here are a group of 7 LEDs. Now, I'm going to put some power in. If you buy one of these things incidentally, that is wired centre negative as opposed to the more standard centre positive. So it's centre negative, so just be aware of that. If I stick some power in and turn it on, now you can see that that's rotating, albeit, oh, let's have a look. There we go, sorry. There we go. If you look at the LEDs, what you have are, they're not RGB LEDs. There's 2 red, there's 2 orange, there's 2 blue, and there's a green in the middle. And basically all they do is fade in and out. Now, if I just put my and as you can see, it looks very nice. It's highlighting the fractures in my crystal nicely. But I think it can be made better, and I think it can be made better by, I'll just turn it on to like LEDs only, by just changing these LEDs to proper RGB ones. You can see there, look. I'll just try turning the power down, just bear with me. Yeah, that's just taking the brightness off them a little bit. So, what's inside it? Well, let's just disconnect the power. It's relatively straightforward. There are some white bungs that go in the screw holes, and they were a nightmare to remove. It is also battery powered, so I'll take the battery cover off, undo the screws, and then the top just lifts off, just like that, which reveals to you then the insides. It's very, very simple. We have a reduction gear here. It's turned by the motor, which then turns the wheel, which turns the cog in there, which then makes the base rotate. Small circuit board. I've just put 1 screw back in. Horrible quality screws, by the way. If you use the wrong size screwdriver, you'll just the ends will just round off with rubbish quality. Typical monkey metal. Right, here we go. Get the other screw out as well. Okay. So really, all you have here is you have the LEDs on a small PCB with a small IC here, which it's obviously it's what controls the brightness. So the plan here is I'm going to reuse this PCB because it has a nicely mirrored surface. I'm going to replace all of the LEDs with RGB LEDs. So that means I'm going to have to bypass this IC. The resistors for the LEDs, and I'm assuming that within probably certain tolerances that they'll be absolutely fine, are already on the board. So as I say, it's just simply a case of unsoldering the LEDs, resoldering the LEDs back in, and then bypassing this IC, as it's just not needed. I had looked at making a bit of error board, but quite frankly this is probably going to be easier, and that's mirrored already. So there you go. Very, 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 very simple circuit. On and off switch. You can either have just the LEDs or you can have the rotator on. As I said, that is wired centre negative, so it's got a battery disable connector in there. Just swap two of the wires over, job done. But this is where I'm going to concentrate. This is what I'm going to be concentrating my efforts on. So I'm going to do a little bit of digging, see what I can come up with, get the soldering gear out and the multimeter, and I'll come back when I've done a little bit more on this. I'll speak to you later. Bye bye. Okay, I have removed all the LEDs from the board. The board wasn't exactly clean to start with, I'll tell you. The more I look at it, the more simple it is. You have, this is the positive line here. As you see, it just comes in, goes into the IC, and then branches off to the LEDs. So simply, all I'm going to do is replace the LEDs, bypass that, because I believe that that's switching the cathodes. I'm just ramping the voltage up and down, and then all the LEDs should come on their own accord. That's the plan. So I shall go and do that now, and I'll show you what I've done to make the hack work, if indeed it does work. The LEDs themselves, nothing remotely special about them, just bog standard water clear 5mm LEDs. The RGB ones, find one. There we go. In fact, what I'll try and do now is I'll just try attaching some current. There we go. Red, green, blue. So, I'm going to stick some of these in. Let's see what happens. Back shortly. Right, I've put the RGB LEDs back in. I haven't bypassed the little processor, and because of that, the LEDs are going up red, look, as you can see, and they're fading. They aren't staying on long enough for their own inbuilt electronics to start the colour change. So my next step now is obviously to bypass that little chip. So that's what I'm going to do, and I shall document it as I do each bit and I've tested it. Right, what I've done is I've removed the resistor there. I don't believe that makes any difference. I was doing it just purely as an experiment. But what I have done here, I've cleaned the solder resist off the copper. Now, I do believe we've got power going into this. Just bear with me. Yeah, those 4 tracks control the LEDs. So once the chip has been bypassed, I'll try and do there we go. Okay. If we keep the current on, you can see that the LEDs will now cycle through the colours. I haven't had to change any resistors. There are resistors already on the back of the board. They are surface mount, but you can see there. So that's all I've done. Just clean that up. I'm going to bridge those together now with some solder. That should bypass that chip altogether, and that should be it. So I'll do that and I shall be back in a moment. Okay, very simply, all I've done is just shorted those pins out, just bridge the entire 4 across. I will trim this. This is just a component lead. I will trim this down, but for the moment it's handy for me just to connect this two. So, right, here we go. Red. Now, because all the LEDs are ever so slightly different, within a few seconds they all start to fade at different rates. So this is where you now get all the variable colours coming from. I'm now going to put this back together and reassemble the turntable, and let's see what the result looks like. Right, I've put it all back together. Let's have a look. Now, once it's gone through its first sequence, it'll start to lose sync, and that's when all the interesting colours and patterns start to appear. Sorry about the noise, the drilling next door. Well, there we go. It's more subtle than the original. Does it look any better? It doesn't look any worse. All in all, yeah, it's a worthwhile little modification. I've also noticed as well, at the moment it's running on about, well, I'll tell you exactly, it's running on 4.5 volts, which is the same as the 3 AA batteries it takes. If I ramp the voltage up, let's take it up to, let's say about 8 volts. As you can see, it rotates quicker and there's a corresponding increase in brightness. But I'm a little bit wary about that, obviously. I don't ever think it was designed to run on 8 volts. But there we go. And that's right down at minimal voltage. That's about 3 volts. Strange, at lower voltage there seems to be more red apparent. Right, there we go. Thanks for watching.